Okay, suppose we can finally start. I'll ask guys from the virtual reality course to be quieter a little bit. And today we are going to continue talking about JavaScript. But first, small recap. What was in previous lectures? We discussed how HTML works. We discussed how CSS works. We discussed a thing called CSS box model, how size of the elements is calculated, and how they affect each other. We discussed different layout models, block layout, inline block layout, ways to take element from the document flow, for example, by putting it to the left or to the right, floating. We discussed the flexbox layout, which is awesome thing if you want to do complex layouts. It can arrange your elements in a lot of different ways and control their width and height. We also talked about some different CSS units you can use in your CSS files, like pixels, percents, EMs, and VW, VH. So, quick note here, pixels are not actual pixels, they are virtual pixels, so on dense screens, the actual size of your page in CSS pixels could be smaller by a factor of 2 or 3. Percents are always relative to the current element, but they're quite weird because sometimes they're relative. For example, margin percents are always relative to the parent container's width, not height. And VW and VH are useful for creating responsive layouts because they are relative to the window size. If you ever see some units like centimeters or millimeters, ignore them because they have no connection to real sizes. They simply scale pixels. The 1 CSS inch is defined by simply taking up 96 pixels. So you have no reason to use them at all. So let's continue. Oh no, not continue. We're talking about responsive and adaptive layouts. That responsive page simply scales its own elements to fit the browser window, while adaptive pages are more complicated. They can move the elements around and transform the web page to look better for different sizes of your browser. For example, if you open your website on a mobile phone, the width would be smaller and you cannot fit as many elements horizontally as you would do on a PC computer. To change the layouts, to change the elements you show on your web page, you may use either JavaScript, as we learned today, or some media queries, as I showed you yesterday, or some flexbox layouts that are automatically repositioned for different window sizes. That was yesterday. I also showed you that the simplest way to get a nicer look of your page is to include the CSS Bootstrap framework. But if you don't like how it looks, you can always override its styles by just redefining them, redefining properties you want to override. So here is a small example of overriding the property. We have a default CSS class, which has background red. And if we later in our code create the default, define the default class again, and say it to have the background blue, actually it will override the previous declaration. So now the default CSS class will have a blue background, as you can see on the right. But we can change the importance of a selector by increasing its complexity. So here I define a selector for the two classes simultaneously. It's 2 times complex than defining a selector for only a single class. So here I say that all elements that have both default class and green class will have background green. And despite that I later redefine the default class to have background blue, this selector has more importance. So if I have an element with both default class and green class, it will have a green background. This is how you would override order styles or your own styles. Yes. Order.
What about defining styles? Like define backgrounds red first and then define backgrounds blue next?
Yes, for the same complexity selectors, it matters. So here I have selector of complexity 1, selector of complexity 1. So this I defined later. Therefore, it overrides all the properties it defines from the previous declaration. So yeah, order matters, but only for the same complexity. So it's like two parameters ordering. First we order by the complexity of the selector, and then by the position. And we started talking about JavaScript. I said that if you ever see an ECMAScript board, it means the same as JavaScript basically. JavaScript has different versions. They're called like ES5, ES6, ES 2016. Most browsers support ES5. All modern browsers, newest versions of modern browsers support ES6. And browsers are constantly updated. But users sometimes do not update the browsers, so you may use special tools, for example, the one called Babel, to compile the newest JavaScript code into the previous versions of JavaScript. This we will discuss probably tomorrow. JavaScript, as I said, is a dynamically typed C-style syntax language. This means that variables can change their types throughout code execution, and C-style syntax means basically that you have all the brackets and semicolons, etc., and all the same operators like and, plus, equals, and so on. We can create variables with the keyword var, we can create arrays with square braces, and we can create objects with figure braces. All values in JavaScript, all simple values in JavaScript, like numbers, strings, or booleans, are passed by value. They're copied each time you reassign them. And objects are passed by reference. So I drew a picture. Here we create two objects, one K2 and second K. And in object K2 we reference the object. In object K we reference the object K2. How does it look like for JavaScript? We have an object K, which references someplace in memory where the actual contents of the objects are stored. And here you can see that the value of object here and the value of variable K2 are basically the same. They are simply pointers to the object if nested keyword there. Yeah. So if I were to change the property k.object.nested, I will also change the property k2.nested. And next we talked about some language features, like strings in JavaScript are immutable. Each time you change the string, you create a new string, so you don't have to worry about the reference things I talked in the previous slides. I also said that numbers are all floating point. You don't have to worry about some things like integer division. You simply divide and it will be floating point. Type conversions are implicit, so wherever some different types, wherever some operations is performed on different types, they will be converted to some rules that are defined. Easiest way to learn these rules is just try. For example, if you add string to a number, the number will be converted to a string. If you add anything to a string, basically this anything will be converted first to the string and then added to strings. We have if then else control sequence, just like in C. Conditions may be arbitrary expressions, and you can have as many codes as you want between the braces. Dicts, objects. So they are stored. This is a nice picture for this. Basically, as in C, you have a heap and a stack, and object contents is stored on the heap. If you know what it is. If you don't worry about it.
They have a key.
Yeah, like
what data structure, like the list from C++ or what would it be?
yeah, they're like some kind of logarithmic structure. So accessing the key is either constant or logarithmic. I don't really know. It's quite fast.
Like block.
I think it's more like a hash map. Yeah. Oh. And we have different cycles in JavaScript, like the for, just like from the C. You can create a variable, set up the condition for stopping the cycle, and action to do after the code is set. So for example, here I start with I equals to 0. I'll iterate while I is smaller than length of the array, and each iteration I'll increase I by 1. And I also log in the contents of the array. We have also the while cycle, which will execute while its condition is true. We have also do while, which is the same as while, but the condition is checked after the iteration. So for example, if I write here while false, it will not execute this part. But if I write here do while false, it will first execute this part and then break from the cycle. And the final cycle, do not mistake this for the same looking cycle from Python. It is actually iterating by the keys of object. So if I have an object with different keys, I can just iterate over all these keys and print the key and the value this object has. And we touched a little bit about cloning, because all objects are passed by reference. We need some way to clone these objects. And we have nice constructions for, not very nice, but I would say like language construction for first level copying them, like taking the slice, which basically copies the array, or creating a new array with the same contents. The function concat, what it does is just merges two arrays, appends array takes from the right to array from the left. So we first have all elements of this empty array, and then all elements of our array. So it just copies the array. And if we ever want to do a tip copy means that we not only clone the array, but also clone all nested objects inside this array. We will need, the easiest way to do this is convert this array to a string and then parse it back to the object. Be careful, because this obviously will not work if you have some cyclic dependencies. It will throw an error if you do this. And to clone an object, we can use either object assign or the same constructions with converting to a string and back. By the way, JSON means JavaScript object notation. It's just a way to represent variables in JavaScript, and it's also a commonly used format for data transmission. I figured it out that object assign is not defined in DS5. It only was added in DS6. So for some older browsers, a polyfill is required to use this. What is a polyfill? Polyfill is basically a small piece of code that adds some feature that is not present. And if the feature is present, the polyfill just does nothing. So, how does a polyfill for the object assign looks like? I've taken it directly from the developer Mozilla.org website, and I grayed out some not important stuff. So what we see here, if not object assigned, the first condition, which basically tests whether object assigned is defined. If it's defined, we do nothing. If it's undefined, we define it using object-defined property. Probably you will have to never use this function in your code. And we set the property assign of an object to the value that equals to this function. And what this function does, basically it creates a new object and iterates over the key, iterates over all arguments of this function, and then iterates over all keys of this argument and copies the key one by one. We can simplify this easily. Oh, it's quite gray here. Okay. We can simplify this code to be something like object assign equals function which does for var I equals 0, we will iterate over the arguments of this function. Oh, not new object equals, we will take each argument and we will create a new object. Yeah. Okay, and for var key in object, we will just add this key to a new object with the same value, something like this. It's the simplified version, but it shows the real thing that happened there. So if I can somehow show both of these two codes. Yep. So here these two codes in comparison, so the meaning of the code and the code itself. Oh, what can I say? We have a lot of complex constructions over there, and they're required for the code that will be constantly reused. But you can use a simplified version for your own code, like if you do not distribute it to other people. One word about arguments. If you access the arguments variable, it's basically an array of all the arguments of the function. Quite simple to create a function that can take an arbitrary number of arguments. So that was quite messy, but any questions? Okay, no questions. Let's return them to the presentation. So if you do not have some feature, you may just add it by adding a polyfill to your code. And now, quite hard part, the prototypes. Prototype inheritance is embedded in the core of JavaScript. You do not see any other type of inheritance there. If you, who does not know what inheritance means? So everyone, okay. Basically, inheritance is when you create a new object that is like a subclass of other objects. For example, cat is like an animal. So cat inherits some features from animal. How can we do this? We can like in C, for Python, we, for inheritance, need to define classes. And their classes inherit from each other. But in JavaScript, objects inherit from each other. So we can create two objects. And if we set the property proton in one of the objects and point it to some other object, now when we try to access some variables of this object, it will first look here. For example, Carl main, it looks here, finds it, and it's Carl. But if it does not find the variable, for example, Carl age, it will go up the prototype chain to the mark and try to find the age there. If it finds it, good, we have it. If it does not find it, it goes up again, until it reaches the object class. Like object, the main object. Everything is inherited. And there are like two objects inherited in the language. First is called object. As I said, it's the main object everything inherits from. And arrays inherit from the object called array. So, is it clear? Nice. So we can make something more complex now. We can actually set some variable. For example, if we set Carl's age to 13, we will add it directly to this object. We will not change anything in the prototype chain. So now Carl's age is 13 and Mark's age isn't changed. This way we can override properties dynamically. Where we can use prototypes? Yes, we can use prototypes to emulate classes. But first we need to understand how functions work. Basically, functions, like in any other programming language, is a piece of code that can be re-executed with different arguments. Here I defined a simple function that accepts 3 arguments. But not like in C, the functions are determined only by its name. So if I define 2 functions with the same name, the latest definition will override the previous one. So here I define 2 function names, first taking 1 argument, and second taking 2 arguments. And basically when I define this, I'll override this function. And so when I call on the right side this function with only 1 argument, it will try to multiply 1 by undefinite, which results in not a number. So if I do not pass arguments, they become undefined. Or I can somehow explicitly say that I want to skip the arguments of the functions by simply writing undefined. And as you can see, functions func name from 1 to works as you expect. 1 comes to arg1, 2 comes to arg2, and they're multiplied. Any questions? Nice. Okay. To understand why this happens, JavaScript will not give you any error. We can think of arguments of functions like of simple variables. So basically these 2 types of function declaration are the same. There is no difference between them. But here we do not explicitly specify the name of the function. So such a function is called a lambda function, or like unnamed function. But for JavaScript, we can call these both 2 functions the same. No changes. Okay, let's continue. And then when we create a function, when we create a variable or a function, it is added to some scope. Scope is an object which contains all the variables, basically. If we define like global variable, just simply by putting it in our code, not inside any function, it will be added to the global scope. And here I represented the global scope by just an object. It will be useful to us. But if I call the function, we can define the local variables inside the function, and they will not affect the outside environment. So So for each function call, the new scope is created. And the variables are now created in that new scope. To illustrate this, when I call the normalize, the new local scope is created, and it first has all the arguments of the function as local variables, and any other local variables we create. So is it clear? Okay. The hard things start to appear when we start linking scopes. If we define a function that uses some variable that is not local to this function, we tell JavaScript to link the scope of this function and the scope it was created. So, if this scope was in global scope, we create the variable p in global scope, and then we create the variable sync in the same global scope. And the sync variable is represented by basically two parameters, like the function to execute to the scope and the scope it was created in. And the parent scope always points to the scope the function was created in. So here the parent scope is just a link to global scope. And now, if we call this function, the local scope will prototypically inherit the parent scope of the function. So if we now call our function sync from 180, and inside this function, the new scope will be created with variable degrees 180, with variable radians, and when we try to access pi, we will not find it in local scope, so we're going up the prototype chain to the global scope and see pi here. And this is how it works. This is very useful because it actually lowers the amount of arguments you need to pass to the function. If you have, for example, 10 variables and a function that calculates something out of them, you can, but it's actually 9 of these 10 variables are constant. So you do not have to pass them every time to the function. You can just pass only one that will change. Any questions here? Nice. So this kind of function is called a closure when we link to some other scope. I've written here also that we should link to non-global scope because actually I haven't seen that someone calls a function a closure if we link to a global scope. If you Google up closure, you probably see something like I've written on the right side. Basically, we have a function that defines another function inside it and returns it. How it works? In global scope, we define our function, and its parent scope is global scope, as previously. Nothing changed here. But if we now call this function, we create a new scope that is prototypically inherited from the global scope, but it now has two variables, the function argument, power, that we passed to, and the function to power that we defined. And this function has the parent scope, not global scope, but its own scope. Now, we return power function. So, the record value of our function is another function. So we can call this function again. It should be power 2 here, not power. So we call this function and we get a 9. How it happens? We call this function, it creates a new scope which inherits from this parent scope, and it has the argument number. So now when we look at this code, what it does, it just takes the number and takes it to the power. And the number is taken directly from this scope, but when we want to take the power, we don't see it here, so we go up to the prototype chain and take the power from here. And then, if we now like take the 3 to the power 2, we get 9. This is like a function. This is what functional programming looks like. It's functions creating other functions. Any questions here?
Can you modify the local variables of function power func from function to power?
Yes. But it's has one little caveat. I should probably demonstrate. Let's open the console. Here's our console. Hey. We open our developer tools, click console here, and now we can write the JavaScript code. So, we defined a function like we did previously, like to power function. Power. And this function will define a new function inside it, to power number, that will return the same math power number power. And now we can define another function, something like change power, new power. That will redefine the power, that will assign a new value to the power variable. If we do not write the var declaration here, it will not create a new variable in a scope. Basically, if you write var power, it's something like scope.power equals new power. Something like. There is no actual variable scope. But if you write just power, there is no the construction for objects that look like this. So it simply finds the variable power in the prototype chain and changes it wherever it finds it, without creating a new one. And actually, if it doesn't find it, it will show an error. And now we can return both these functions in an object, like to power, change power, change power. And we now call this function from power 3. If we now call power, if we now look what power is, what power error is actually an object with 2 keys, as we defined it. Like one key is to power, the other key is change power. We now can call this function to power, for example, from number 2, and we receive 8. But if we now call change power, for example, to the same 2, and call it again, we take 4. So this is like the way to create like something like objects in other languages, something like classes in other languages. You simply define a function with some local scope that will hide all the private variables and expose only something you need. Any questions here? Okay. Where closures are actually useful? Because you can simply do math power and like 2 variables is not quite a good example. Closures can be passed, for example, as event listeners. So when something happens, an event is generated, and all the event listeners attached to this event will be executed. An event listener is simply a function. So you can, for example, easily, as we see later today, create an event listener that changes your own objects, like we did with Power. Something like that. Now the most disgusting part of all of this is functional object-oriented programming. If we want to write classes, we actually can do it. What we do it via functions. If we want to do some sort of a class, you just create a function that will act as a constructor for this class. So here our constructor takes one argument, name, and it says this.name equals name. And also it defines a function. This.meow equals function meow name. And so look, meow and its name. So now we can use the keyword new to create a new object, empty object, and this empty object will then be passed as this to this function, and this function will set its property name to name. We provide it here, and it will set the property meow to the function. And now we can lock the pinky name, and it will print pinky, and we can call the function pinky meow, and it will meow. So this is like a simple way to create to instantiate some objects with common functionality. Basically create classes. Any questions? Okay, is it clear? Okay. It is getting a little bit hard. Every time you create a new object, this function is re-executed. So every time you create a new cat, the script will create a new function. And if you have, for example, 1,000 cats, you will have 1,000 different functions with different scopes linked to them. We can simplify this and only create one function for every cat. But we now cannot link the scope. So we have to use this. So how does it work? Each function has a special property called prototype, and we can edit it, add a new function, add a new content, basically functions. So here, cat, I add a new property, meow, to the cat prototype. And when I now call new cat, what will happen? The new empty object is created, but it will not be empty. It will have a linked prototype to the cat prototype. And then the constructor is executed, and we add also a name here. And now, if we access pinky.meow, it will not find it directly in this object, but it will go up to the prototype chain, to the cat.prototype, which will have this meow function with some code. So this is basically a memory saver for us. We now take 100 less space for this function, or 1,000 times less space for storing this function. But this prototype thing also can give us class inheritance. We can now create two classes, animal and cat, and say the cat prototype is an animal prototype. have animal.prototype, which has nothing. It's empty object. And cat prototype has the same property, which is linked. And the object is still contains the values we defined. So how it works? If we now call new cat, it will create this new object, link its prototype to the cat prototype, which is already defined, which has a prototype, animal prototype. And later in this function, it also calls a function animal on this, and this function is called with proper this, and it takes the name. And then this object we can use for our purposes. Yeah. Any questions? Maybe repeat it some different way. So basically, in normal language, it will look like something class animal, something like animal name. This name equals name. And then class cat, something like extends animal with the function meow. Meow. That doesn't. This is just the weird syntax to create some sort of stuff. And if you do not like this syntax, I'll have a good news for you. In ES5, in ES6, we actually can use classes. But they simply do this thing, creating like a lot of functions and prototypes and so on. It's useful to understand how it works because it allows you to write your own inheritance chains. But for the web, you would not find yourself writing inheritance chains a lot, because everything is quite simple. But you can use it, for example, for companions. You may have something like a calculator and an engineering calculator. And an engineering calculator will have all the properties of the calculator, but also something more. So we can save the amount of code we write by using the inheritance to not repeat ourselves. And I think we now can have a little break for 5 minutes. Oh, yeah. Okay. I think about this before the break. Sorry. This is dynamic. So, whenever you call pinky.meow, this will actually become everything you have to the left of your dot. So, it's not actually attached in any way to the object. What does this mean? We cannot use this in the animal constructor. We have to use a special way to call a function called call. We could just write animal name, But since we have no dot here and nothing to the left of it, for this call, this will be undefined. And to set this explicitly, we have to say animal.call pass the this we want and all the other arguments. For now, arguments of our function is name, and this is the same this we have. Okay, let's continue. Now I will try to gradually switch from the abstract JavaScript to the JavaScript actually that does something with your page. Now we will write a small calculator. How we will do it? First we will design it. By design I not mean graphical design, I mean like the arrangement of the elements and the core functions of this calculator. And then we will write the logic and then attach this logic to our page. So let's start by design. I think we will write a simple calculator that is looking like rectangular shape with some number input here and a grid of buttons. Buttons with numbers may be useful for people with touchscreen devices. With touchscreen devices, so they can input something without going into input mode. And some default functions like adding, subtracting, dividing, multiplying, equals,
Dot.
Something like this. And how would the data flow in this application? So basically have some user who will provide us some numbers. Number and who will click on buttons. And we have two different types of buttons. These buttons will actually input something in our text, like input buttons. And other buttons are like action buttons. They will somehow change the contents of the same. So it's good to think of this calculator as a complete component. So it needs to have like some place to store the number and a little bit of memory, because user needs to input two numbers, like the first and then the second. So to do this, we will create a class calculator. That will, by default, create an empty array of numbers. Not empty, but the array of one number 0. This will be our default number. Now we can add some functions to our calculator, like on input button click equals to the function of content. Content of the button. How? By clicking on the input button, we should modify the number. We should modify the number we currently have on top of these numbers. So to do this, the easiest way is to take these numbers, the first element of the array, convert it to string, and add the content of the button. This will not prevent, and then convert it back to the number. So this is currently a quite erroneous function. It will do something wrong if we, for example, press the dot button 2 times, but it's okay for now. And then we can do calculator, prototype.
These the numbers.
Oh yeah, these dot numbers. Now we can do calculator prototype add. Is actually a function too. What it will do, it will unshift an array. So, okay, this will. Okay, this will not. Okay, I don't remember how unshift works, so I just do it using concat. Concat these dot numbers. These dot numbers. And we actually need to set something like this dot operation equals to plus. Yeah. Something like this. Same for subtract. And so on. And the final button we need to do something with is the equals. It will now check this operation. We can do this either by doing a lot of ifs or by switch operator, but I will currently do a lot of ifs. So if operation is plus, we take these numbers from 0, add to these numbers from 1, and set it to these numbers, like this. And so on. This code is quite dirty because it doesn't check that we have actually two numbers here, or something like we cannot divide on 0, but we have no division here, so it's okay. You can make it better, for example, if you come home. Now we can create a new calculator instance. Calculator equals new calculator. And do something with it. For example, calculator on input button click 1. And we can check that it works by examining the numbers array, and we see 1. Let's now click button 2, and it's 12. Let's now click dot, and it will not work because when we convert it back to the number, the dot was lost. So we need to change our function here, the function on input click, so it will not convert back to the number. We can do this by simply overriding it, like this. Yeah. And then we should actually change the equals function, so it would convert these two numbers to numbers, so they will not be added like a strings. Yeah. And if we now recreate the calculator, recreate the calculator. We can check that calculator on input click 2, on input click 1, on input click dot, input click 0 will give us the right number. We can, of course, add something like if number is 0, remove it, but it's up to you. It will not affect the actual calculations. And if we now press something like add, and now let's examine the numbers, we see the new number appeared, and we can input new values to it, like 1, and then dot, and then 2, and examine numbers again. Now if you press equals, we should see the result of the summation. So this is our simple calculator class. We can instantiate it many times. We can create a second calculator, which will have completely independent contents of the first calculator, and will operate independently of each other. This will allow us to create multiple calculators on the same page by just using the same code. And now we need to somehow provide an interface for the user. And to do this, I will have to actually take all this code and rewrite it quickly. Calculator. These numbers equals to 0. This operation equals to null. Calculator prototype add equals function. These dot numbers equals 0. Concat these dot numbers. This dot operation equals to plus. The same for subtract. Minus prototype equals function. If this operation equals to plus equals because this is a comparison, these numbers equals to these numbers. This number 0 plus these numbers 1. This operation equals to null. Else, if this operation equals to minus, these numbers equals plus this. And the final function to actually input some numbers, prototype on input button click, function content, this number 0 equals these numbers 0 plus string plus content.
Haven't you missed the class in -4?
Yes, but it's because it's minus, it will work still. I should probably change the coloring scheme.
Maybe it's not right.
View probably. I don't know how to change the color scheme actually. References maybe.
Works somehow.
Color scheme. Yeah, that's nicer. So, here we have our calculator code. What have I pressed? Yep. So, here we have our calculator code. And what we need to do? We need to create a page.
Change equals to plus in plus part.
Yep. So we can save it now in somewhere, like seminar 3 calculator.js. Now we can create a new file, index calculator.html. No, thank you. Create the default layout for our HTML page. And now think, how can we actually present this calculator via HTML and CSS? We should think in terms of like grabs of elements. The topmost grab is the calculator itself. So we like define this as our first div element because it has no special properties, it's just a grab. And now we have like horizontal division, first row and the second row. And it is a good usage for flexbox actually. And then this element is also like a subgraph. We can do this as a table or as a flexbox. I said that you shouldn't use tables for layouting purposes, only for displaying tabular data. So let's use flexbox in both of these places. So what I need to do, I'm creating a div called calculator, and inside it I create the div class calculator input, and I'll put input type text in it. And I'll class it something like calculator input area. And now calculator class calculator buttons, calculator buttons row, and then button class calculator buttons. And just simply create a lot of buttons. Yeah, something like this. I'll throw it to the left side, and now if I were actually to open this web page, I'll see something quite resembling of what we actually need. Input bar and a lot of buttons. But we could add a little more style to it. To do this, we will attach a new style sheet. Real style sheet, ref style calculator.css. And we will create this file, calculator.css, and write all the styles we need. For example, calculator would be display flex, flex direction column, calculator input will take up the whole width, and calculator input area will do the same.
You specify that it will be flat bottom and just write display flex.
Yes. By writing display flex, I say that my calculator, so this thing, this container, would have a flex layout. So its children will be arranged in flexbox manner.
And if you just don't specify anything display, you assume that it will be
A block layout by
block
default.
layout.
Yes. Actually, not always. We sometimes want to use a block layout. For example, a little thing here, actually, block layout. No, when we say display flex, it will only change how children elements are positioned. But the element itself, for the outer, for its own parents, will be positioned like a block. But if we say the display flex with the parent this element, yeah, it will become a nested flexes. So like when I say display flex, I mean that all children of its element will be displayed in a flexbox manner. But this calculator itself will be displayed however its parents wants it to.
When you use, for example, bootstrap, is it specified? Will it be block layout or flex?
You can create an element and see in the developer tools what is it by default. For example, buttons by default are inline, and something like a form by default is block layout. And actually, as I know, Bootstrap is not using Flexbox layout because it has some backwards compatibility. Yeah. So actually, the only one, if you use Bootstrap, the only thing where Flexboxes can appear is from your own code. Let's just see how it goes. I will probably want to say that the width of the calculator will be something like 200 pixels. Yeah, as we can see, the input extended to the 200 pixels. We may also add a little border. Here, and a little padding here. And as I said before, it's wise to use box sizing border box here. And now we need to lay out our buttons. So we go to the calculator buttons and say that it will be also display flex. Flex direction will be column, and calculator buttons row, right, will be also display flex, but flex direction will be row. Oops. Yeah. Now everything is kind of messed up, so we need to specify the width. Nothing happens
Do
for
something to auto.
what?
Flex.
Oh yeah, flex, align items.
So what's up the job?
Xbox. We want to extend the items so they take up equal amounts of space. So we take something like
Flex row.
no, flex row is no row by default. We can say justify content. No, not justify content, and not align items. What can we do? Align not align content. Hey, interesting. Let's try justify content. Justify content. Let's say space between. Oh, because it's need to be here, buttons row. So we have like now evenly spaced buttons around, not quite good. Let's say space around, yeah, a little bit better. But now we want to say the button should take all space it it is allowed to take. So we have like width 100%. And now all the buttons are taking up equal amount of space.
Look at the buttons row class.
What?
Buttons row class.
Yeah.
For logic.
Let me show you by using the developer tools. Oh, it's too big. Okay. Here we have a calculator, and it has two parts: calculator input, calculator buttons, and
Okay.
each button row is itself a button row. So button rows are displayed from top to bottom, and all the content of a single button row is displayed from left to right. Let's add a little bit of spacing here, and probably somehow offset our input from the buttons.
What is the default value for width?
By default, width will be determined by the content of an element. It's actually, we may specify width auto, and it will be auto-calculated. So for most of the time, it will depend on the actual what's inside the element. It's useful for texts, for example. So the more text you have, the more width and height the element will take. But sometimes, as here, you do not want to specify widths based on the content. You want to specify it outside, like, yeah, black. Yeah, here, as you can see, the border looks not good because it's attached directly to the input, so I should probably change margin to padding. And here it is a little bit better. And maybe add a little bit something like margin top 20 pixels from here.
Why is it specified that calculator class should be flex?
To
On the buttons to be flex.
I specify the calculator to be flex, so input and buttons would be underneath each other. Basically, I could just say that calculator should be block and nothing will change. Yeah. So they're under each other by default because they are blocks. So yeah, you're right. We do not need flex on the calculator. But I don't know, let's leave it so we would have some consistency. So we actually explicitly specified that we want our calculator to have input and buttons underneath each other by saying flex direction column. Okay, and now we need to somehow attach our JavaScript code to all these buttons. To do this, we will first include our code in the page. And as you can see in our code, it only defines functions. It do nothing when we include it. So we need to write here a little bit of other code that will be executed after this code because it's after, and actually attach somehow our calculator to these buttons and input. To do this, we may either use the included in JavaScript library called Document Object Model, DOM API, but we can also use a simple library called jQuery, which wraps up the default JavaScript and provides a more easier interface. The easier interface. So you can write less code if you use jQuery than you would have to write if you just use the native JavaScript. So to download jQuery, as with Bootstrap, we may use CDN, using jQuery with CDN. And where is the link? Yeah. Here we can see 4 different versions of jQuery we can use: uncompressed, minified, slim, and slim minified. Basically, there are 2 different versions, like complete jQuery and light jQuery. Let's use complete jQuery. And now we should use between uncompressed and minified. Actually, if we open, we just see a lot of text. This is actually a JavaScript code that will be executed if we link jQuery to our page. A lot of JavaScript code. So the difference between uncompressed and minified, as you can see, the uncompressed code is cleaner but takes a lot more space. But they are completely identical for the browser. The only thing different is for us when we read it. So it's good to include the uncompressed versions for debugging purposes, so you could actually understand what's going wrong if something goes wrong. If something goes wrong. So let's just take up this link and include it in our page in the same way. So now,
If I want to include not jQuery but Flow, JavaScript, what is the difference?
what do you mean?
jQuery is rewritten.
No, not rewritten. It's just wrapper. So you, for example, have function in JavaScript that are defined by the standard, and the browser implements them. For example, like document append child. Yeah, and the jQuery will provide you a different function called $sign that you can use in many different manners. I'll show you. And inside of it, it will actually do the calls to the document append child. But for you, it will be a little bit simpler because the less code you have to write. So I have included a jQuery, but you can still use this document if you want.
Without including jQuery.
Yes, and after including jQuery, you still can use it. It will not go anywhere. So opening up our calculator, updating the page, and as you can see in the network tab, we now loaded 3 files: HTML, CSS, jQuery, and for some reason we haven't loaded our calculator.js. Probably because I have a wrong name. No, the name is right. Script src equals, let's do this. Yes, now it works. So now it loads 4 files as we requested it, including the jQuery. And now jQuery simply, we can see the error actually that happened when this code was executed. And we can see that it's on line 25. Let's go to line 25 and see that I have mistaken here. Update, no errors. No errors is good. You should always have no errors. And now, because we included jQuery, we now have a global variable called $, defined here. As you can see, it's actually a function. It's actually a function. And how can we use it? The simplest way to use jQuery is to call it and provide a selector. Selector is provided just like in CSS. So we can write here calculator, calculator input area. And it will return an array-like element which consists of one element, actually this input. If we now define a different selector, like calculator buttons, calculator button, which have many items, it will return an array which have all the items that match this selector. And now, for example, you can do something with these objects. And the things you can do are displayed, are listed, I should say, in the documentation. Here, all the cool functions. For example, we may change the CSS and say background red. Now all buttons became red. We may actually do another change and say color white. Now all our buttons are white. So this is how you manipulate your elements from the JavaScript using jQuery. You select them and then apply some transformation to them. We can actually remove them, for example. Or we can create a new element, add a class to it. Let's like var new div equals div. We can add the class, call it calculator button, and then this new div we may append to jQuery calculator buttons row. And what it will do, it will take our element. Oh no, I did wrong. Instead of creating new element, I selected all the divs in my page and added them a class calculator button. And as you can see now, all divs now have this class. And it will affect their presentation. Let's update the page to restore it to initial state. And now, if I really want to create a new div, I should write this code. Surround div with braces. And now I can add class to it, calculator button. And now I can append it to all the calculator buttons row. Now we see the new button appeared here. Let's look at it. But it's not button, it's a div. So it displays differently. And it also has no content. So you see it like a blank square. If we want to add some content to it, we can use the function text and specify the text it should has. New div1. But when we append it, we actually clone this element, so we now cannot access this button from this variable. But we can reselect it, like calculator button. And as you can see, our added button is a div, so we can select only these new buttons by using div.calculator button, as we would use in CSS.
You always select by classes. You always select by classes.
Yes.
But if you have ID, you can select by
Yes, you can select by ID, you can mix them up, you can select by text. Basically everything you can do in CSS, you can select here.
You also could select by text.
Yes. As I showed here, I now select all the divs that have the class calculator button. And I now set their text to 1. Now we have a lot of 1s here. And this is how you manipulate the page with the jQuery. You can set not only text, but also the whole HTML fragment. We can nest a new div inside it, like here. Nothing changed for us, but as you see, we now have calculator button, and inside it is another div. What else can we do? We can remove classes.
When you write select dot something, what is after dot?
After dot is a class name. Oh, here?
Yes. If you write
Yeah.
HTML or text, go.
Yeah, okay. When I perform this function call, it returns me an object.
Yes.
you can see that this object is called like jQuery fan init. But the thing about this object is that
It's Java object.
JavaScript object, yeah.
Yeah.
It's some JavaScript object that looks like an array, but also, as you can see, it has it has a different prototype with a lot of new functions like add class, like CSS, like text we used, and basically all the jQuery functions are here. So if we now call these functions from the prototype, so after dot, I accessing the property of this object, like remove class, it will search for this function in this object.
And this is jQuery function.
Yeah, this is functions defined by jQuery, and the object returned by this call, by this function call, has this property, which is a function, and it's applied to all these selected elements. So now I can remove class calculator button from all my div calculator buttons, and as you can see, nothing changed because of the dot. Yeah. Now I removed this class, and as you can see, now my div class is empty. Okay.
How do I create a property of the? I have an object and I have some property. How do I create property as a method?
By simply defining this property as a function. So I can create an object t equals to some prop function console log I was called. And now I can call this function and it will print I was called. Okay, and now this actually does not help us to do something when user clicks on the button. And to do this, we need to understand the events. When you do something on the web page, the browser generates an event. And event is first passed from the root body element to the bottommost element, to the deepest element in the tree, in the DOM tree it could find. So it is passed, for example, now to this button. And then, after it passed down to the bottom, it goes up again. It's so-called bubbling up events. So, with jQuery or without jQuery, you can subscribe to these events and call functions when they happen. So what can I do? I can select all my buttons and say on click, I want to call the function console log I was clicked. And now, when I click on any of the buttons, I see the string I was clicked printed in the console. But because event is bubbling up, I can also listen to the, I can also select the calculator buttons and and subscribe to the click event on this element and console log calculator buttons was clicked. And now if I click on the button which is inside calculator buttons, I'll see two messages displayed. So again, events goes from the bottom of the tree to the top. First it affects the button, then it affects this div, then it affects this div, and then it affects this div. This is useful for sometimes when you need to prevent something from happening. If you click inside some container, maybe. But as you can see, if I click on this input, nothing is printed because this input is not in the way of events bubbling up from button or calculator buttons.
Now, if you will read between the buttons,
Yeah, it will print only calculator buttons was clicked. So, is it clear? Okay. Let's then update the page and actually prototype our code. I'll create a new calculator, and now I can select the calculator buttons, but I don't want to select all of them. I want to select only the number ones. So I should add a new class to the number buttons, like number.
how did you do it?
Huh? Oh, it's a feature of Sublime Text called multi-cursor. You can basically select multiple lines and write code simultaneously.
Which button you selected?
What?
How did you select it?
I just select the word, this word, yeah, and press Ctrl D or Alt J, depending on your key scheme, and it will select the next occurrence of the same text. So I can, for example, select button and select the next occurrence of the word button. But okay. I added a class number to all of the number buttons, and now I can reload the page, reload the page, and select only buttons that are number. And on click, I can access the button that was clicked by using this. Information about it you can find in the documentation .on. Here is a lot of text about how it works and what events you can use. But now I will just console log $wrap up this in a jQuery. This is the third way to use jQuery functions. Just wrap any object around it. And this .text. So what it does, if I now click on 9, yeah, I suppose let's do it again. Calculator button number on click function console log this, and then console log $this .text. And now it's actually logging. As you can see, console log this logs up the element that was clicked. But it is not a jQuery element, it's just a native JavaScript element. So it does not have the function text. So we wrap it up in a jQuery object to gain access to this function. And then we can actually get the text of the button.
But why write it only one time? You load it 2 times via JavaScript and via jQuery.
So it's logged 2 times, yeah, console log, yeah. I write two.
It should log.
Yeah, and it's logging 2 times. First it's logging the object, and then it's logging its text.
Okay.
And it only works on the numbers I mark, or on the buttons I marked as numbers. And now, if I create the calculator object, I can add another listener, or first of all I can remove all previous listeners I have added by using the off function. I now removed all the event listeners, and now it doesn't print anything. But I can add another listener again and call the calculator on input button click and call this function with the text of a button, like this. So I take the text of a button I was clicking and push it to the on input button click function. And now, if I press, for example, 8, 9, and then look at my calculator.numbers, I can see that these numbers are added to the text. And obviously we now want to update this input with this text. To do this, we will have to, first of all, save the code we have written, for example, in this script tag. var calculator equals new calculator, and then we write the code calculator calculator button number on click function calculator on input button click $this $text $this dot text. So we now save the important part of this code. We can update the page safely. And actually, if we update the page and click on the button, nothing will happen. As you can see, number is still 0. To understand why this happens, we should recall that scripts are executed immediately after browser loads them. So first browser loads this script and it is executed, and then this script is executed. And only then the body contents are parsed and the actual object is created. So we need to delay the execution of our script after the page was created. And the easiest way to do this is to simply take up the script and put it in the bottom of the page. So now when browser comes here, it will have already created our page. So like everything is executed from top to bottom. Now if we update it and click and call the calculator numbers, we see that numbers are appearing. Okay, let's continue. To update the input, we should understand where the value of input is coming from. And you may remember from previous lectures that the value of the input is specified as the value attribute. I can specify the value attribute and change the input. Or it goes the reverse way also. So now, in our event listener, we should not only call the calculator on button input click, we should also select our input area and set its value by using the function value from jQuery to the calculator numbers 0. to the first number of our calculator.
Shouldn't we convert it to number now?
It will be automatically converted back to the text. But it is already text.
Now text.
Yeah.
Here is
Inputs
next
are-
to 0.
Yes, nice idea. But you should probably handle extra 0 inside the calculator code, not inside the presentation code. Okay. Nothing works. Let's examine why. Open up the console and see the errors. Value is not a function. And value is not a function because if we open the documentation and write value here, dot value, we don't see this function, but we see the function dot val. So we could just call not value but dot val. Now finally we can input some text into input using buttons. And as you can see, when we click on plus, nothing happens because we haven't attached any listener to the plus button yet. So let's do it. We should add a class to distinguish between class button and the other buttons. So we open up our HTML, find the plus button. Here it is, and add the class plus. And also class minus here. We will ignore division and multiplication for now and add a class to the equals because we will need it. And now we can use calculator button dot plus on click, call the function, and calculator add, and also update the input.
Why do we need to deal with extra 0 in JavaScript? Because here we need to have the minimal code to combine elements of the page with the logic.
Yes. The problem with leading 0 is that because we're adding numbers,
Okay, it's about
why we cannot
the
just write it
image.
simply here?
No, it's like we should have all logic in that file with the first file we wrote, and here we need only to connect page elements with that logic.
Yes. It's not a, like the strict rule,
Yes.
but it's good to follow this principle so you can reuse the calculator element and maybe attach it to different page layouts. So because the 0 treating is actually happens inside the calculator, so we need to remove the 0 inside the calculator. So if it bothers you, I can just simply take the on button click functions and add an if here. If this numbers 0 equals to 0, we say this numbers 0 equals to content. Empty string plus content. And else we simply add. So now no leading 0 will appear.
Or we can convert this number 0 to a number by plus, but then it will work as well.
What about the dot? If we will then be unable to specify the dot. Okay. Finally, when we press plus, calculator now asks us to input a new value. And before it will actually happen, let's write a function calculator button equals to do something when we press equals button. On click, function, calculator equals. Calculator input area, just simply call this code again. As you can see, we copy pasted one line 3 times, so it's time to separate it in separate functions, but for the sake of simplicity, I will not do it. So now, if I write 456 plus 654 and press enter, I will get the correct summation result. And this is our first interactive element on the page. So I will post this code in the canvas as soon as possible, and I suggest you to come home and add actions for all other buttons, and probably add some code so we will not be able to enter the second dot, because now it will just returns a none if we do this, and make this calculator better. Yeah, so I think that's all for today. If you have any questions, please ask. It's really important to understand how to manipulate the objects on the document, even more important than understanding the prototyping inheritance. So yeah, please try and play with it. And again, thanks for coming, and see you tomorrow. Thanks.